Hi everyone. In this first lecture, I will go over the course structure and the outline. Let's start with a quick look on the outline. For each section, I will give information about how the theory and implementation parts will be structured. As I always do, I try to make this as practical as possible. In the introduction section, after giving the course structure and the outline, I will continue with a summary of the basic use cases and then the advanced use cases that you will learn and implement. And then I will mention about the requirements to set up your local environment. Then the second section will be about Java and AI with an introduction to Spring AI. Then following with various use cases for Spring AI chat client applications with OpenAI API, Google Gemini Vertex AI API, Hugging Face, Ollama, and Docker Model Runner examples. In this section, you will also understand the working principles of chat client and chat model in Spring AI and learn using multiple models in a Spring AI application. Then you will use Open Web UI to use local LLM models visually. In third section, I will continue with advanced Spring AI features by extending the previous examples to use different response types and streaming option, using structure to output, using various chat options, and applying advisors for pre- and post operations for a chat client. Then I will revisit the basic examples to learn about prompt engineering best practices with 0, 1, and 5 shot, and also chain of thought prompting examples using system messages, returning multiple results, limiting token and cost usage, and also adjusting creativity and controlled variability with temperature, top P, and top K variables. And then finally learning to use prompt templates. In section 5, I will touch on prompt guarding by using system messages, and also prompt hacking, jailbreaking, and prompt leaking techniques, and the possible mitigations with various examples. In section 6, I will give a break to mention about generative AI and LLM fundamentals, mentioning about the foundation stones such as learning types, transformer architecture, attention mechanisms, tokenizers, embeddings, positional encoding, and token prediction based on probability. I will try to challenge the question of whether an LLM can actually think by giving an example of decision-making paths of LLM. I will then mention about the LLM model differences and choosing a model based on various factors such as allowed tokens, benchmarks, context window size, and latency. Then in section 7, I will switch back to practical examples, and this time introduce chat memory with a use case of order status helper. I will start with in-memory chat memory, and then switch to jdbc with Postgres for persistent memory, and then finally use a vector store with pgvector to hold and use persistent memory more effectively. I will use different chat memory advisors and use memory options. In section 8, I will start with multimodality with image-to-text generation with a relevant use case to apply a visual compliance check. Then I will continue with text-to-image generation with a marketing asset generation example using OpenAI image model DAL-E3. I will then continue with multimodality, this time introducing text-to-speech and speech-to-text generation, again with some relevant use cases, using Whisper1 to build a use case for a smart meeting assistant for the speech-to-text, and the ticket status voice notifier for text-to-speech use case. In section 9, as a preparation to advanced concepts such as RAG, tool calling, agents, and MCP, Model Context Protocol, I will list LLM limitations and their mitigations. Each mitigation will actually be bounded to an advanced concept, such as to prevent hallucinations, you can use RAG grounding, tool calls for facts, schema validation, and structured outputs. Then in section 10, I will introduce prompt stuffing, RAG, and vector databases. I prefer to call prompt stuffing as in-prompt context, so after a basic in-prompt context example, I will continue with RAG details, with splitting and chunking strategies, embeddings, vector databases, and similarity search. In this section, I will use two RAG use cases. One simple RAG flow to create a mini employee handbook, and then an advanced RAG flow to create an QA over internal documents with PG vector as a vector store, with customized token size, using a PDF reader, and also using query expansion and applying a re-ranker model to improve the final result of RAG. In section 11, I will go into the agent world with tool and function calling. First, I will explain why tool calling is required and how it is performed. Then I will introduce agent patterns, difference between self-decided and workflow-based agents, and then apply and implement an advanced AI agent with a real use case. The agent will perform a security review analysis and find security breaches for a given architectural diagram, first by analyzing the image, then getting internal postures of the services mentioned in the diagram from an internal web service using a tool call. And then it will perform a similarity search to the vector database similar to the RAG flow we created in the previous lecture, and then finally doing a web search on common security-related websites such as OAuth to finalize the result. And then it will return a summarized response with suggestion and improvements for the architecture that is mentioned in the diagram. After that, in section 12, I will introduce MCP, Model Context Protocol, and then update the AI agents from the previous lecture to change the posture service to an MCP server and create an MCP client for the agent to be able to call that MCP server. You will then see how to test the MCP server using MCP Inspector. Finally, in section 13, you will add observability features to the AI agents and RAG flows that were implemented in the previous lectures. You will learn to use Spring Boot 3 observability with Actuator, Micrometer, and Prometheus, send logs to Loki using Promptail, and visualize them in Grafana, and then send metrics to Grafana using Prometheus to visualize them. And finally, send the traces to Tempo using OTLP, OpenTelemetry in Spring AI, and visualize them again in Grafana. I will also show how to use Jaeger as an alternative tool for trace tracking with a nice dashboard. Great! After this introduction, in the next lecture, I will continue explaining the use cases that you will develop in this course. So I will see you in the next lecture.